Hi everyone, I'm Ruchita and I welcome you all. We have people from different geographical areas. So, good morning, good afternoon, good evening, wherever you are. I would like to welcome you to a 3-day webinar series on the topic of analog space mission. And for this webinar series, we have a speaker who is none other than Eleonore Poli. And I would like to introduce you all to her. She is a PhD candidate in material chemistry group at Cambridge University. And she completed her MPhil by research program at the same department. She studied material science and engineering before obtaining a bachelor's degree in mechanical engineering with specialization in material and processes. Her current research focuses on studying of crack initiation and propagation in protecting coatings for the power generation of gas turbine blade applications. Apart from this, she is a huge space enthusiast. She has worked as the crew commander for the AstroCapsule Mission 1 and also is the founder of the Conference on Analog Space Mission. Apart from this, she is a person of vivid interest, I would say, because she is an athlete. She likes to play piano as well as she likes to do photography as well. And she's fluent with various languages like French, German, English, and Russian as well. So, hi, Eleanor, and it's so nice to have you. I welcome you to the webinar series.
Thank you so much for the introduction and thank you for being here today, everyone. I hope you really like this and really fire questions away at the end of the presentation. I look forward to seeing them. I will share then my screen if that's okay.
Yeah, you can try sharing. And also, I have a question. Like, I did introduce you, but we'd like to know more a bit about you from you. Yeah.
Tell me, what do you want to know about me exactly?
Okay, so I would like to put it this way. I'm very sure our audience is very curious, like me, and would want to know your story of interest in science, engineering, and especially analogs, like how you got into this.
So basically, I've always been interested in science. So as a kid, I wanted to be an astrophysicist or environmental engineer. I love space, but I also loved machines and robots. And I wanted to solve environmental problems by building machine. I was never really interested in doing just simulation. I was like, yeah, I want to build a machine and I want to help. And anyway, so I was reading lots of books, and then when I was, I think, 12, then I started studying math and physics in school, and high school again. High school, I wanted to become a military pilot also because in Switzerland it's neutral, so you can fly airplanes, but you don't actually kill anyone, which is really, a plus because they're such beautiful aircrafts. I mean, I love those aircraft and I love the adrenaline. And then I was preparing to start university. I knew I wanted to do engineering or astrophysics, but I didn't know about material science and engineering. And then I saw a presentation, I realized actually this is what I want to do. And I don't mind studying astrophysics on the side, like reading books, but I don't necessarily want to do research on it. I prefer doing like something that is directly applied, which is not always the case with astrophysics. So I started doing material science, and I was always fascinated by space and aeronautics. I studied different materials for aeronautics and aerospace application, and I want to become an astronaut. And 2 years, it was 2 years ago, a bit more, I was on Facebook and I follow lots of space pages, obviously, because I'm a space nerd. And they said, astronauts wanted. And I knew that the European Space Agency hadn't made a call yet, and that NASA had we're doing an application the year after, something like this. Like I knew it wasn't either of them. And I checked and I see analog space mission. And I was like, what is that? And I applied. I was the first CV they received. And 2 months later, I was selected as an analog astronaut. 4 months later, I was elected crew commander. And because of COVID, it took us time, but about a year and a half after this, we had the mission. And I'm going to show you some images today, and hopefully, like you'll be as fascinated as I was enthused by it.
That's amazing. Like I hope like the people that are attending today would also find like most of them must be new to the concept of analog. So they'll find their way into this. So all the best for the participants. Do hear it and put your questions in the chat box. We'll take them up at the end. And with this analog, you can start presenting.
Yeah. Perfect. So can you see my screen or not?
No,
I just need you to tell me because I can't see you, so I need you to tell me.
no. We can't see your screen actually.
You can or you can't?
Can't. I can't.
You can't. Okay, so I'm gonna try because it says it's sharing, but I don't know how we're gonna go to space if we still can't get to share stuff, you know. No, I know. So I'm gonna share the entirety of my screen that usually always works. Sorry, guys, you're gonna see your own faces. Can you see my screen? Can you
Yes.
see it?
Yes.
Okay, perfect. Cool. Super. And it gave a bit time for other people to come in, so that's great. So welcome to the webinar again. Rashida already introduced me, but just tell you a bit the content about what are analog space missions. I guess a lot of you don't know what they are, want to know a little bit more about it. So I'll go through the kind of habitats, the protocols, the life support systems, the scientific experiments we do, but also the analog astronauts, you can see there, and the different roles that analog astronauts have. It's not only about, doing funny faces like we're doing right here, but it's also other aspects. I met Rashia through Habitat Marte, so we did the analog space mission together virtually. But before that, as she says, I'm a material science engineer. I was the commander for AstroCapsule and obviously astronaut for this. I worked at Pilatus Aircraft as an intern, and I'm really into analog space mission, which is why I founded CHASM, which is the conference on human analog space mission, which would take place in 2 months. And if you're interested, you can tune in on YouTube in 2 months, and then you can hear about different analog space missions. So yeah, do shoot me an email and I can send you the links when they are out in about 2 months. But basically, what are analog space missions? So you might think, okay, how do we prepare for space? We don't just prepare the rocket, we don't just prepare the spacesuits, we prepare the people, we prepare the protocols, we prepare the life support systems, we prepare the logistics and communication, okay? It's a very, very dangerous environment, okay? It's not a normal environment. It's very remote. There's lots of things that can go wrong and people can die. So the best way to prepare for space missions is to prepare for them on Earth, for example, or underwater. So you can't always simulate the lack of gravity. You can do it a bit in water, and I think Rashira will talk about this tomorrow. So you can put a spacesuit on and train underwater, and you can see that you're a bit less able to or nimble. You can't turn things easily, or you weigh a lot and you're like, oh my god, I can't move really, really well in this water or this spacesuit. But basically it prepares you for the space mission or the EVA, so the extravehicular activity you would do in a spacesuit. But there's actually lots more to prepare, and it's much cheaper and much safer to do it on Earth. So, for example, this is an image from the Mars Desert Research Station in Utah. It was funded by the Mars Society about 20 years ago. So that's some of the oldest analog space missions. And what they do is they have, as you see, those habitats and people with spacesuits, and the simulate missions in there. And the purpose and the reason why we're doing those analog space missions is to make sure that the space missions that we have work. And it's not just also like a little flight to the International Space Station or such. Now we're actually preparing to go to the moon, and we're preparing to go to Mars. And the moon, you could say, well, you go there, you stay a few days, and you can stay in your lunar module like they did in the 1960s and 1970s, and then you go back home. But actually, when we go to Mars, we're not going to be like 6 months there, 2 minutes there, and back, right? Not going to happen. Not only do you need to prepare for those 6 months of travel, or a bit less, by then maybe we'll have, a bit more powerful rockets, but you will need to create a settlement there. And for this, you need to test the habitats. So the psychology is very, very different. The habitats are very, very different. The people that you will put in there are also very different. Like the first people that you sent to the moon, there were people who were very brave and not always, they were okay, but not mainly very empathetic. But when you're doing a 1 year long space mission or even longer, you need people who fit together and people who can talk and communicate very, very well. So Habitats, first thing. So here you see me. This was in one part of the tunnel doing my analog space mission with AstroCapsule 1. This is in Hawaii. This is the high seas analog space mission. And this was an analog space mission I was supposed to do in Iceland this summer, Chill Ice, which is what from Euromoon Mars. I can send you all the links after, so don't worry if you can't take notes. I will send you some names so you can look them up. But basically, you have to test those habitats. Why? Because obviously where you're going to sleep and where you're going to do your experiments, when you're going to eat and everything is the most important thing, right? Because if you don't have this habitats, or if you don't have a spacecraft that works, then you will die. Okay, you are in an extreme environment. You will not last in your spacesuit, or you won't be able to do any experiment that is actually really worthwhile. So one thing that we're looking into for the Moon and Mars is to stay into lava tubes. So this on the left is a lava tube in Iceland. And basically they are natural formation of lava tubes, and it makes a pocket. And in there you can just put your habitat. For example, this tent over here. Well, it's not really a tent, it's more rigid, but so this habitat, you can put it inside it. And what is really good about them is that you have naturally, structurally something strong. So it can protect you from, for example, storms or, rocks falling or asteroids, whatever it could be. But also it usually provides you with radiation protection. Because we are not on Earth, we don't have an atmosphere that is that thick. So on Mars, the atmosphere is very, very thin. On the Moon is also barely there, which means that you don't have protection from the sun, and also you don't have the same magnetic field also, which also provides protection. So because of all those lacking conditions, you need something that will naturally shield you. And I can tell you, we're not going to take a lot of concrete and build, a building on top. We're not going to do this. It's way too cost consuming. So the best way is to find something that is locally already existing, and that you can go and put your habitat in it, and you have natural protection. The other thing about habitat is I don't know if you've seen some of the Soyuz capsules and things like this, but you can barely stretch your legs, right? And if you're staying there a few hours and it's just for the lunch, it's fine. But if you're going to spend weeks or months, not only will you have probably problems with your legs, but you will also be completely uncomfortable. You won't be able to work. So eventually you need habitats that are much bigger, and you need to test the comfort. And this is something that you can test when you do analog space missions. So for example, the Chilas mission, what they were doing is they had 48 hours where they took a habitat, and they took it and they put it inside this lava tube, and they were just testing it and seeing, okay, is it easy to put? How do we feel psychologically? How does it impact you? What kind of resources do you need? What kind of tools? Because you can be stranded on Mars, and you can't, drive to IKEA and say, oh, can you give me this screw because, I need to build a shelf. It doesn't work like this. You are alone. You are, months away from Earth. So you need to, on Earth, test what you're going to need on Mars or on the Moon. Now, protocols. So here you see one of my fellow analog astronauts. That was Manuela. So right now it's more about hygiene. So you might think it's not very important, but actually it is very important, hygiene, because if you're sick, then you cannot, perform well. And for example, in our mission, we were in a base underground, 450 meters underground, 1.5K away from the surface of the Earth. And the humidity was about 89% and 13 degrees Celsius temperature. When you have humidity that high, what happens is you've got bacteria forming. And if you don't have the right soap or, things to disinfect, then you could be ingesting bacteria that develops, and then you could potentially be sick, and then you can't do the mission. So for us, on the first day of the mission, we realized we don't have soap. But I noticed that we had vinegar in one of our experiments that we were doing in the science tent. And I was like, well, if we take probably vinegar and also we can put some boiling water, then we should be able to disinfect well enough that we should stay safe. But this is something that you need to be able to plan. You need to understand also, like, is your hair going to start, being just one crust, or can you really wash yourself? So this is something that we test on the International Space Station. We know people can wash, but then you also think, well, if we're going to spend 2 years or 3 years on Mars, what are we going to do? Here you see my colleague, she's using a dry shampoo. Basically, you just put it on your hair, and then it stays there. It means that you're saving some water and saving other stuff. Regarding safety, I'm not going to show you the video here, but basically, we were woken up during the mission at I think it was 2:30 in the morning, and we had a protocol in case there was a lunar quake. So in case you have an earthquake on the moon, obviously if you're in a habitat, then you some stones might fall on you, or you might have some damages, or the experiments might get damaged. So we had an alert system, and depending on the alert system, we had this much time to evacuate into the airlock, which was the safest place. We do a checkup on the other astronauts, and then once we know that the earthquake is gone, then we know, okay, well, you can get out of the airlock, you put, a helmet to be safe, and in case there's, for example, a leak of air, because obviously if there's a hole in the habitat, you don't have enough atmosphere on the moon or on Mars, so you need, you won't have enough oxygen, so you put your spacesuit, make sure you got oxygen, then you go out and you inspect the whole base and you see, okay, is there a crack, is there any problem? All of these systems that you would need, you have to test them on Earth, okay? Because that's where you might realize, actually, we forgot this, we forgot to put the spacesuit in the right place. For example, our spacesuits were not in the airlock, and that could be potentially dangerous, or we calculated how much time it took us to evacuate and we realized, well, maybe we took a bit too much time, or it could be anything, but these things you have to test, and they do test it on, for example, the International Space Station. Now, one thing that you might not think is important is the Mission Control Center, but basically it is something that you also test in analog space missions. And the reason for this is because you need to understand what devices you need, what additional equipment you might need, and how does a communication delay affect the mission? What do you need to tell your astronauts? What is necessary? How do you talk? Do you say, hey, hi, do you have a good day? Yeah, can you tell me, can you ask this astronaut guy, can he come here? It's not efficient, okay? It doesn't work, right? Often we had missions, we had two astronauts who were wearing a spacesuit doing a walk outside of the base, and we had one astronaut communicate inside, and he was communicating, or she was communicating to the Mission Control Center. And if the Mission Control Center took a minute to say something that takes 5 seconds, then the astronaut in the base could not hear what was happening to the astronauts that were on extravehicular activity, EVA. So it was really important that we kept really concise and straight to the point. So you say base to MCC, base to MCC, do you copy? And say base copy, and then you say astronaut Ogalde is on EVA right now, procedure 1, 2, 3 have been completed, and that's it. But basically it's very important that you develop those protocols and you test them. And the other big thing is on the ISS and on Earth, you barely have a delay. When you communicate, like you can have almost a phone call, but when you are on the moon or when you're on Mars, then you have a much longer delay. So, for example, the analog space mission from the Austrian Space Forum that happened in October, I know that they implemented a 23 minutes delay between their communications, and they tested basically the psychological impact of it, because it means that for 23 minutes, you're alone. If somebody's having a heart attack, you have barely a few minutes to help them. And calling Mission Control Center, if you have 23 minutes delay, is not probably going to help, right? But if you were on the ISS, then it would probably make help, because then it's more or less an immediate call. So these things you have to test, and it's not something that we normally have on Earth. There's no place where you have such a delay unless you're sending, 4 terabytes of data, and then it's just data. It's not a phone call, right? So basically these are the things that you test. On the left you see basically a normal, like a regular mission control center, where you see satellite paths and lots of people like flight engineers, or the head of flight plan, so basically the person who decides on your schedule. And on the right, this was what we had for the analog space mission. So even for our analog space mission, we did an analog space mission in the way that we did a rehearsal. So for 48 hours, we simulated our 8-day space mission. We were in a basement. Here you can see me and my colleague, Julien Corsin. and we were in a basement, and basically we were communicating with them here, and we're testing all the protocols and seeing what was working or not. And you have some people, so you've got the Capcom, the direct link, and then he and the others hear what you say, and then he or she replies to you. So for example, you have what we call the biomedical engineer, who will give you advice on if you have a health problem, or you have obviously the flight plan head, who will tell you, well, we're going to modify your schedule, etc., etc. So never underestimate the role of Mission Control Center. They save your life. They're here to help you. They will make your whole schedule and decide of most things. But sometimes the fact that they're distant will have a great impact and great change in the way that we do space mission. Now, scientific experiments. So one of the big reasons that we go to space is for science, okay? Obviously it's beautiful, but that's where you have the difference between somebody who goes to space for a few minutes for $1 billion and astronauts who work as astronauts, okay? So when you go to space, you are usually testing a lot of biomedical things, for example, influence of medication, osteoporosis, and just the effects of lack of gravity. So we know, for example, that obviously you have a bone density reduction and muscle density reduction. Cardiovascular systems work not as good when you come back to Earth, because obviously you don't have the same stress in space. You develop eye problems that usually resolve when you get back to Earth, etc., etc. So we know these things, but then we can test, other stuff. For example, 3D printing of materials. This is one thing that we can also check for Mars. So you think, okay, well, why would you test the experiments during an analog space mission? Because the main thing in space is the lack of gravity. That's one of the main things you want to see. Well, you have to think of space again. You can't ring Amazon and they will come and bring you stuff, okay? They are far away, okay? Earth and the tools and the boxes and whatever you might need, they're far away. You can't get it like this. And usually you don't have much time, okay? If you're doing experiments with cells, they will die, or you don't have the same enough energy or oxygen or anything that you might need to do these experiments. You have a limited supply, okay? So time is of the essence, and therefore the objects and tools you need are of the essence. And this is something that we can test with analog space mission. So for example, on the left, it's me and a colleague of mine, Sophie Lismo, we were doing the experiments on soil filtration, and basically we're trying to test, it wasn't Martian soil per se, but something similar to it. We're trying to filter the perchlorate out of it, because the perchlorate is what makes it not fit for agriculture. So we were testing some devices, and we were testing the methodology, and it took us way too much time. The filters kept breaking, and we had to change the whole flight plan because of this experiment. So it was fine. It was a bit stressful in the way that we wanted to do some extra things. But what was the most important thing was that we didn't have the right tools to do it in a certain time. And if we had been on Mars, then it could have had possibly large consequences. Because, for example, we did not manage to do our whole sports workout. And it was fine because we were on Earth. So our cardiovascular system was not getting damaged, per se. But if we had been on Mars and we had to, not do sports because we were doing that experiment, then it could have had life-threatening impacts if it was happening regularly, okay? So this is where you see it's important. This is where you think, okay, actually we don't have this in material, so you have to replan everything, or you have to have this object ready. We were also missing plugs, we were missing magnets, we had to find alternatives. It was really, really cool. It was really, really cool to just find another way to jump on top of it and find a solution. But it was also very, sobering, because you think, yeah, actually, if your scientific experiment is not ready, is not good to go, then it has impact on the whole mission. And usually when you go to space, you also check things such as the material that you want to use. As I was mentioning before, it's nice to have a habitat that's already ready on Mars. But if you can't, you might want to try and 3D print the local material to create habitats. And this is something that you want to test maybe inside your habitats, and it can be one of the scientific experiments you would like to check. So yeah, this is for scientific experiments. Obviously, there's also all the psychological experiments, but these are a bit more, they depend a bit less on analog space mission. They're obviously very, very important, but it's more about isolation and duration. And actually, I guess some of you could even fill questionnaires about isolation. When I joined AstroCapsule 4 months later, we actually had the COVID pandemic started, and we received some questionnaires saying, well, how do you feel about isolation? And they were very similar to what they ask astronauts. So yeah, in this case, you can see psychology obviously can be tested in space, an analog space mission, but it has slightly less of an impact on your flight plan. Now, life support system. So on the left, you've got an ice cream sandwich. I don't know if you ever tried it. I had like 3 of them in my life. Because every time I have a friend who knows I love space, they usually give me one of them. And they're really delicious. It's really cool. But obviously, if you were to spend a year in space, you wouldn't want to eat that the whole time, okay? And you don't realize, but actually food is extremely important when you're in locked space. I mean, maybe some of you, you get angry when you're hungry, and you don't work as efficiently, and it's a tough job being an astronaut. I mean, you're up since maybe 6 or 7 in the morning, and you work sometimes till 10, because even when you do sports or when take time to relax, it still counts as work. So you don't have the same needs. You usually spend way more calories, and you need to be way more focused than a standard job. So this food is extremely important, but you also have to check CO2 levels. In analog space missions, usually they don't do this CO2 level check. You can see them, but you don't have a filtration system in a closed loop, but you could. And this is one way to also simulate the stress that you would have in space, knowing that if your CO2 filtration system fails, you will probably die, okay? You can also test the water recycling system. So obviously, usually it's extracted from urine. And you can also test the air filtration and pressurization systems. For my mission, we were 8 days on the mission. So we had 8 days and a bit more food supply. And it was very interesting to see how food was impacting things because, for example, we didn't like the protein shakes that we had. So we were compensating with some planted chicken. It's a vegan chicken that we were using. And we really needed this. And we were eating everything that was given to us for the day, really. We didn't leave any rations because the base system, the electronic system, basically failed because there was too much tension on it. And we were working at a temperature of 13 degrees instead of 18 degrees Celsius. And when you have this 5 degrees temperature difference, basically you feel cold quite a bit. So even if you wear more clothes, in the long run, you use way more calories than normal. So basically, we had food that was planned for a certain calorie level, and actually we needed it a bit more. So we were eating different rations, and it was quite interesting to see the impact. Regarding the air filtration system, we had a quality check of the CO2 levels. So we knew, for example, before the mission, we had lots of journalists coming in, or we had people installing things, and we could see the CO2 level was rising quite a lot. It wasn't dangerous per se, but we could calculate basically that if 6 astronauts were doing sports at the same time in the base, it could potentially be a bit problematic, and we would have to check things. And the other thing that we were checking, for example, was radiation levels, because we had a granite in the rocks, and basically it's slightly radioactive. So we also had to check that kind of level. On the right, you see an example of plant that is grown in space. I think it not only is a good life support system, it provides you with your, fresh air and this natural filtration system. It's also natural food, but also it provides a mental health aspect. Often the color green is very pacifying, and it gives you hope, and it helps you and connect with Earth. So it's not only just a life support system; it's a mental booster to have that kind of thing. We actually had plants. I'll show you later some pictures of plants. We had plants inside our base, and we had like a light that would create UV so that we would have enough vitamin D for the week. And we would take our plants and kind of smell them and feel them to kind of connect with them and just always have this connection to Earth. Now, analog astronauts, I'm sure you're all interested in knowing. So here's a picture of our airlock. So this was just before the mission. So here you see the tunnel that we were in. It's a tunnel that is in the Grimsel Pass, which is in Switzerland, and it's under a mountain. And if you continue that tunnel, there's actually a hydraulic center. Basically, you have a dam on the top, you have some lakes, and here they generate electricity. And on the right-hand side of the airlock in red, you have actually a testing center where they do material experiments, nuclear waste storage experiments, etc., etc. Really fascinating place. If you can go there once, it's lovely. And basically, here we had our airlock that you see my colleague Julien opening. On the left, where the A is, we had the toilet. And if you continued in, we had 2 tunnels, one top tunnel and one bottom tunnel, where we had our science tent, our bed bunkers, our sports station, our kitchen, and even a hammock and some places to relax. But basically, before we got there, we actually had to go through a selection process, okay? The recruitment process depends a lot on the analog space mission. Some of them, they're just like, I'll pay some money and you can get in as long as you're interested. And others, they do a really, really tough, recruitment process. For example, for AstroCapsule, it was based on the European Space Agency's recruitment tests. So it was quite tough. And when I did the recruitment, we had, I think, all 4 steps in less than 2 months. It was really, really just boom, boom, boom. So you send your CV and motivation letter, obviously. So what we look into for your CV is that you love space or you're very interested in it, that usually you have an STM background, but that's not always necessary. What's necessary is that you are able to repair stuff a little bit. So if you're not somebody who's manual at all, if you don't understand any electronics or you don't understand any sort of, do-it-yourself skills, then it's a bit problematic because you have often to maintain the base and you have scientific experiments to do. So if you're not naturally good or interested in it, it can be problematic. But technically, you could be a linguist and still be, an analog astronaut. We need people from every domain to join space, especially if we're going to have colonies or, settlements on Mars. So you send your CV and motivation letter. You say if you have any experience also in an extreme environment, if you're good with teams, if you have empathy, if you also, you know how to lead, but also how to follow. If you're too much of a leader, it's a problem because, you don't want one person to say, no, I decide, and then mission control center doesn't get to say what they have to. It doesn't work like this, okay? You need to be able to be both. And once you pass this first stage, stage A, you have to send a video. This helps us in checking your English skills. They're very important because usually you have an international team. And even if you were to be 6 astronauts who don't necessarily speak English as a first language, you might have a mission control center who will need to communicate to you in English so that we can, listen to the recordings or, we can have, again, an international team. So this video not only says, okay, he's got or she's got good English skills, but also tells us your motivation. What do you want to be an analog astronaut? Are you curious? Or do you want to be an astronaut? Or is it just for your CV? Is it just for your CV? We don't want you, you're going to be with other people. You're going to have to take care of other people. You're going to have to, you're going to have to do some scientific experiments. So you can't just be interested and that's it. You want to really want it. And also, it's not necessarily a very comfortable environment. So if you're not used to being uncomfortable, you're not going to like it. And this we might also see in your video. Then you have cognitive tests. In the cognitive tests, we also do small psychological tests and a little bit of this do-it-yourself skills. So, we see if you know what an electric system is or, any just basic skills that would be needed in the base. And finally, if you pass all 3 steps, you have psychiatric evaluation, fitness, teamwork skills, and an interview with astronaut Claude Nicolet, which is our only Swiss astronaut. And the psychiatric evaluation, what they're looking for is to see how you react under pressure. If you're the kind of person who blows up or, panics and, you just, don't do anything, you're useless. You're actually dangerous. You are dangerous because you're not taking care of your other teammates. So we can't have this. And if you're somebody who explodes and yells, then you're making also the rest of the team, stressed, and you put them in danger possibly, or, you're not following procedure. So you need to be able to tell someone, okay, I react this way when there's stress, when people are unwell, when maybe there's an accident, or any experience that you have can be useful. For example, when I had my psychiatric evaluation, I was asked, have you been in any sort of danger and how did you react? And I told them the story of I was paragliding and I was with an instructor because I don't have my paragliding license. And we jump and we had a really nice view. We had a view on the mountains, view on the lakes. It was a beautiful day, really, really great. And then while I'm up there smiling like an idiot, I hear the teacher say, "Uh-oh." And I was like, "What do you mean, uh-oh?" And it's like, "I think one of the brakes is blocked." And because I don't have my license, I didn't exactly know what it meant. I didn't know if it meant we were in direct danger or not. And I was like, "Okay, are we in danger?" And he was like, "Well, you know, the wing might collapse and then we might crash. So we need to put the weight on the other side." And I was like, "Okay, look, if we're going to die, please tell me. I mean, we have time. We're still flying. I got my phone in my pocket. I'll take my phone and I make a phone call. Say, bye mom, bye dad, bye sis. Love you guys, and you know that's it. You know, but at least I have time to do this." And then in the end, we managed to land. We crashed in the pool, but nothing happened. It was fine. And the psychiatrist was like, "But how did you stay so calm?" And I was like, "Well, because if I panicked, we were going to die. If I didn't panic, there was a chance we'd make it and that it wouldn't be so terrible." This is exactly what they will be looking for you if you apply, for example, to AstroCapsule or also to be an astronaut. It's like, are you capable of staying calm and doing what needs to be done to stay alive and to also keep others alive? One of the other things that we'll be looking at is obviously your fitness. You will have to, as I say, to have long days, often carry stuff, or you know, you sometimes you have to sprint up and down when there's a moonquake. So they need to know that you fit enough, obviously, to like be okay in that kind of situation, and also teamwork skills. If you're the kind of person who cannot stand to work with others, it's a big problem. You need to be empathetic. You need to understand others. You need to be, you know, come forward. When you see somebody needs help, you come to them and say, "Okay, can I help you? Can I help you? Can I do this? Can I do this?" Maybe they will tell, "No, it's fine," you know, but you need to be proactive and you need to love working with other people because you will be in a tin can for quite some time. And if you can't work with others, then it's not a good job for you, basically. But one thing that is I have to mention when you applied to being an analog astronaut, as I said, we were interviewed by astronaut Claude Collier that you see on the right. So this is a picture from when he was repairing the Hubble telescope. He was on the space shuttle missions, and he was really, really amazing. And he's been an absolute wonderful mentor for all the people from AstroCapsule. And on the left, you see Alban Michon, who's a French explorer. He helped us do ice diving and basically train for the mission, to train in extreme environment, to train team skills and survival skills. And both of them were absolutely crucial for this mission because not only did they bring us together, but they keep us dreaming. And basically, if you have people like this in an space mission to mentor you, it's such a win because you get to hear the stories, you get to meet them, and you get to be inspired by them every time. So this is one of the big mentions. When you join an analog space mission, you will always meet fascinated people and often people just like Alban and just like Claude. Now, the training. Obviously, once you have your astronauts, once you have your habitat, you need to train the astronauts to get in the habitat and do all the experimental and scientific things. Okay, so you have extreme environment training. Here you can see me. I look extremely sexy with this. You know, it's like perfect outfit. I was doing basically dry suit diving. So you're diving under the ice, and this keeps you dry. So under it, I'm actually dressed, or like a t-shirt and trousers and whatever, but it keeps you completely dry. It's just your face that gets really, really cold. And then we did ice diving in the mountains. So it was temperature outside was, I guess, minus several degrees. And the water temperature was just under zero, obviously, because you had this much layer of ice. And we were cutting, you know, a bit of ice, went into the water, did some diving, and then went out and just you know, we're helping each other to stay warm, communicating, and was absolutely fantastic training. It was the first time that we met each other, like the astronauts, for the training, and it was really one of the best weekends for all of us, I think. Then the other things that you have to train is psychologically. So it's not just, that you have team building. You need to also understand each other. So for example, in our psychological training, we were also learning to ask others, okay, what triggers you? What makes you angry? So for example, I don't like when people chew loudly. Others don't like when you turn a page, Others don't like when you don't put a blinker. Obviously, this is not really important in space mission, but it's the kind of thing where you have to be aware of the other person. And additionally to this, you need leadership training, right? Because every astronaut has a different role. I'll present this later. But basically, if you don't feel confident or you're not able to take leadership, you won't be able to carry out the mission well. Okay, it's not just the commander who needs to lead. Every astronaut inside the base will have some responsibilities. Okay, and if they're not confident, if they can't endorse this and give orders and say, now you do this because I am the specialist, then you have a problem. Okay. Communication, mentioned before with the Mission Control Center, obviously you need to have clear communication, but that's also true between astronauts. And it's not just the kind of words we use, it's also thinking, okay, when should I communicate and what is important, right? For example, if you have an astronaut that is feeling sad, are you going to call Mission Control Center right away, or are you going to come to them and like say, okay, what's up? Do you want to talk? Do you want to do something? Okay, this is also a kind of communication that is really important. And then there's also all the communication, as in the devices, the reports, the computers, the walkie-talkies, the radios, anything that we might use. This is also part of communication. First aid and hygiene training. So you're in a remote place, okay? If one of us breaks their ankle, or falls on their head or anything, the ambulance would take at least 20 minutes to get there. Okay, so for the 20 minutes you are on your own, you will need to provide first aid training. So all the astronauts, we had to go through first aid training. And 2 of our astronauts were actually trained to be medical officers to provide extra training. So I think they should be able to perform amputations and that kind of thing, but they didn't have to, which is great. We all have still all our limbs, so we're really lucky. Public speaking. You might think, why do we need public speaking for our space mission? Well, today you're listening to me. I had training for public speaking. And the reason for this is, for example, in the case of AstroCapsule, we were completely sponsored. So we didn't have to pay anything. People were paying us by, giving us computers or, giving money or giving food. And the only way we can thank them is by giving speeches and talking to media and making their product famous or making the mission famous. And the more we talk about it, the more we can recruit future analog astronauts and, we can better the mission. And this is true for all analog space missions. They need this public speaking, so people who love space, who are really qualified to do it, will come and see it. So this is one of the training that we had to do. And astronauts also do have that kind of training because they are the ambassadors of space. You don't realize how many people are in the space industries that are supporting astronauts. You just see the astronauts. They are the face of the mission. But actually, there's like hundreds of thousands of people behind all space exploration and engineering. So yeah, public speaking actually quite important. And then there's nutrition training. It's more important than you think. As I mentioned before, food is quite important, and just keeping it clean, so not mixing too much, knowing when to store what and how, also keeps your food safe from bacteria and not making you sick. And then obviously there's all the scientific experiments that you have to train. These depend a lot on the mission and the base maintenance training. So if you have a specific base, then you have specific training as to, for example, the water supply or the CO2 filter system or just electricity. All of these usually you receive a training or you will learn during the mission, like we did. Now, different roles. There's the commander. I was the commander for AstroCapsule, so my role was basically to see that both the crew and the mission go well. So you have the health officer, they check, your vitals and, they're a bit aware of how people seem to be. But in general, the well-being is not just your body, but also your mind in general. And if I see that an astronaut is not doing well, then I know it also impacts the mission. And I also make the link with the Mission Control Center and tell them, look, the crew seems to be like this, like this, like this. It seems that the flight plan is a bit too packed. So you need to remove some tasks for us so that we can do this well. Or this astronaut seems to be not loving this kind of task. Can you please shift this to this other astronauts, because I know they can manage this better. So my role for like 2 years was to really know my crew, know what triggered them, know a bit how to manage them, how to give the feedback. And if there were to be any problem, I would be the one overseeing the evacuation procedure. So in case of a moonquake, I make sure that my whole crew is there, that they're all safe, and you give orders and yeah, you stand by. Why is a commander important? When everything goes well, you don't need a commander. Okay, when everybody like is very independent and works really well and there's no danger, you don't need a commander. But when there's a problem, for example, somebody is a bit rebellious, or you have a moonquake, or you have, I don't know, a solar flare, something like this. This is when you need someone to say, we do this now. Okay, this is why you have to allocate a commander. But if you're lucky, you don't even need to use your role, basically. Then you have the communication officer. So usually they check in the morning, in the evening, that all the communication equipment is functional. Sometimes it's good if they have a background in computer science, that kind of thing, but it's not necessarily necessary. It's like, it's just as long as you understand how things work and you make this communication link. I mentioned before, the health officer might or might not have to amputate someone, normally not. But basically they take the crew vitals also daily and they report it to the biomedical engineer, which is in the mission control center. We have also a payload officer. Usually they oversee scientific experiments. So they know basically what kind of experiments we have on board. They know most of the procedures and they can assist the other astronauts if there's any questions, and report then quite well to the mission control center. And finally, the base engineer, they usually maintain the base integrity and just all the systems. And they usually have quite some background in engineering. So my key things about analog space missions is we had, for example, 10 rules for our space mission, but I would summarize it to safety first, mission second. Okay. The safety of your crew is the most important thing, because if your crew is not safe, the mission will not happen. Okay. Either they will die, or they will get injured, or they will feel too stressed to perform well. It is not a normal environment, both in space and both in analog space missions. You are either on the ground, underwater, isolated. It's not a normal condition. It's not just you walking down the street. Okay, so you have to remember this, that safety first, mission second. But obviously, always try to get the mission working, right? Don't take breaks every 5 minutes because you want to, okay? When you end there together as a team, and not just a team of astronauts, but the whole mission control center, all the people that organize everything. So you have to think about the mission too. But save yourself first, okay? Same like when you're in a plane, you're about to crash, and you've got the oxygen mask coming out. They tell you put the oxygen mask first, then help others. Okay, you first save yourself so that you can then save the mission. It's the same thing. My second thing would be work with passion and quality. Okay, if you love what you do, you're not really working. Okay, for me, the space mission, I mean, I wasn't sleeping that much, and we were working the whole day, and it was a bit cold, and not really stressful, but very busy. But it was fantastic. It was amazing because I had this passion, because I was with highly motivated people who really love what they did, and because we did it with quality. If you don't do your experiments well, or if you don't, send your psychological evaluation tests to the right person because you botched it and you were like, oh, I'm too tired to do it well, then somebody else has to do the work for you, or you have to redo the work. And time is of the essence in space missions. You don't have that much time. Usually you're really working all day. So if you do it with quality, you won't need to redo it, and then you'll be fine. And then lastly, enjoy. Really, it's a very specific and peculiar environment. It's a wonderful environment. It's a wonderful thing. A lot of us will never get to be astronauts. Some of us will get to be astronauts. But the fact is, you don't necessarily know. And an analog space mission allow you to kind of test these, to pretend to be an astronaut, and you do almost just as good as an astronaut in the way that you do those experiments. You provide data for the scientific community, you provide data for NASA, for ESA, for JAXA, for whichever space entity, and you also develop passion in others. That is so important when we want to go to space. So really enjoy. And here you see some of the pictures I thought you might enjoy. So you see that we're not always very serious. So the left-hand side, it was Julien Corsin and I just before we went for an EVA. So we went the airlock. So we have the webcam so we can, explore stuff. I think there we were doing a leak check because we had a leak coming out of our base and wanted to inspect it. So you have to wait for procedures, and then you come out of the airlock, and then we took pictures, and then you write a report, and then you do a debrief. On the left-hand side, it's Claudine. It's a little plant that was offered by us by Claude Nicollier, and it was part of our morning rituals, just smelling the flower and connect to Earth. On the right-hand side, you can see part of our food. So all our food was put in inventory. So each piece of food had a label, and we had recipes for every meal. So we knew exactly how much food we had every day, and we would remove it from the inventory. So the Mission Control Center could also see, oh, they're going to run out of food or not. And it was all labeled and all installed in there. And it was extremely good. We were really, I was impressed. Like you wouldn't think that tin can food could be so good. But maybe we were also very hungry. But I think it was mainly that it was extremely well prepared recipes. In the center, you see Sebastian Ogale. He's making a phone call with family. So you don't have that much time, but it's important that you also connect with your family and, provide news and stuff like this. So there he was on a phone call with his family. And behind him, you can see actually the fitness center and the hygiene center. So we just had this blind so that you could have a bit of intimacy. And on the right-hand side, you see this was in the mornings. We had Mission Control Center doing a report. So you have a briefing every morning where they tell you the activities for the day, and you just give them updates of anything important, any question. And he wanted to cheer us up, so he put a mustache on his face. And left, you can see the crew. So this was, I think, the last night of the mission. We decided to take pictures together, and yeah, motivation was really high. In the middle, you see James, is one of our plants who started blooming in the middle. On the right-hand side, it was after the mission. You can see part of the whole crew that helped make this mission happen. So really don't forget that you are astronauts only because there's a team on Earth that supports you, makes everything happen. And the left-hand side, it was, I think, just before we left, we were just hugging the people who helped us do this. Alfie Roy here, who was one of the project co-leader, and Chloé Carrière, who was the other project co-leader, both fantastic people who helped these things happen. And in the bottom and on the right side, you can see that was when we did extreme environment training camp, where we were sleeping by -7 degrees, ice diving, building igloos, and just getting to know each other. So yeah, I guess it is question time.
Yes, it is. And it was really an amazing presentation. And I'm very sure that the audience must have a lot of key takeaways to take home and process and think about it. So let's start with the questions. And we have Sebastian. He says, if analog mission didn't exist, where could people find activities that resemble the experience of an analog astronaut?
It depends what you want from the analog space mission. For example, there's actually lots of analog space missions. So if you want to do the activities, just sign up for one already. So because there's lots of opportunities, but I can send you some link at the end. Other activities you can do is you can think about the extreme environment. Okay, so if you look at our training, there was the whole part about surviving extreme environment, ice diving, skydiving, camping. Going to the Arctic Circle, for example, that's a good way to do an analog space mission. Or you could be doing other stuff, like, for example, you were in isolation maybe because of COVID. Well, how would your isolation have been if you had planned your whole day, activity per activities, and you had somebody else telling you what to do and when? And you calculated how much food you were eating, how much water you were drinking. You had to, perform certain scientific experiments. You could actually do it yourself and think really about this schedule. I usually have to, optimize my day, not minute per minute, but almost hour per hour. I know exactly what I do. So I'm doing my own mission control, but it's a better test if somebody else does it for you, and it really optimizes your day. And yeah, it feels a bit like you in a mission, it's quite cool. But best is just apply for an analog space mission.
Yes, I mean, like if he just wants to experience the extreme conditions, like he could even visit the Atacama Desert or Utah for, extreme environments. You could just go and live there with the local people, and you'll get a general idea about how things go on in the extreme environments. There's another question from Sebastian itself. Were you not an analog astronaut, what role would you enjoy in the mission control?
Huh. Ah, good question. I don't know. I think I would love most of it, except maybe the record. Like I didn't like the one where you have to, write down everything that's happening. This I would not find that interesting. It is obviously interesting, but I would like something a bit more with adrenaline. And I love the contact with astronauts. So I love, managing teams. I love talking to them. So probably either Capcom or flight plan probably would be like something that I would find interesting, because then I have to take into account how the astronaut's feeling, what is the information I'm giving them. I have to readapt all the time. So it means I'm busy all the time. I think that would be the two. But anything is interesting and cool in mission control too.
I would love to do an in-person analog mission because this is really fascinating now. Okay, we have Shivam, and he says, "What is the minimum qualification for an analog astronaut, and can it be used as a plus point for a person who's trying to apply for like a real astronaut training?"
Of course. So if you apply to be an analog astronaut, the fact when you apply to be an astronaut, the fact that you were like, okay, during my holidays, I'm gonna spend, I don't know, a week or a month in a tin can for fun. You're already the right kind of person, okay? We like when you want to be in space, you're not gonna have the same comfort. You're gonna have to, work for humanity about doing those experiments. So if you already do it in analog space mission without the perk of being in space, then you're already the right kind of person usually. So yes, it's definitely a plus, and also it's all experience that you learn. Like if you manage to stay 1 month in the Utah desert without losing it, then it's already a very good sign. And you can use this expertise when you have your interview to become an astronaut to say, well, look, I have this. I know I love how to work in a team. Didn't kill anyone for a month, and everything went well. So it's obviously a massive perk. And then the qualification for an analog astronaut himself, it really depends on the analog space mission. But for me, it would be always that you know how to work as a team, that you're resilient, and you're passionate about space. These are really, like, if you're not resilient, as soon as there's a problem, you might give up or you might panic. Or if you are resilient, if you're used to, stuff failing all the time, and if you're super flexible, then it's not a problem. So these are the main thing, is like, because you can always get an engineering degree, or get a bit more information on do-it-yourself tools. These things you can do. It's not necessarily easy, but you can. But the most important thing is really this resilience and passion, really, and obviously talking to other people. If you hate people, then yeah, you're not gonna have a fun time.
Yes, and we have Shreya who says, like, is it always the case that analog astronauts actually go to the space?
No, no, not at all. So like, there's not that many positions to become astronauts, and the reason is because obviously it's way more expensive and way more dangerous. So, if, for example, you could have analog astronauts who have some medical problems that would be unacceptable in space, but are acceptable on Earth. Okay, because it's not as dangerous and doesn't cost as much money. Like, I'm not gonna train someone and spend millions of pounds on them if I know that they have a large heart problem and they might die in space, and then they might put at risk other people. But if they are on Earth, it costs less and it can still contribute massively to science. And I know they probably won't die. Or if they have a heart attack, then we can come directly and save them. You can't afford to put people at risk in space. On the Earth, it's not exactly the same consequences and not exactly the same cases. So that's where you could say, well, you have more analog astronauts now than you have astronauts. Okay. And the other thing is, as said, it depends on the analog space mission. Some of them, they really filter you out. AstroCapsule, they really do a thorough filtering, but others, they don't. So somebody that would be qualified to be an astronaut wouldn't be qualified to be an astronaut. Okay. So yeah, that's why it's not a guarantee. But as mentioned before, it is a massive plus.
That's true, right? Yes, Nitish, who says where to apply for this astronaut positions, and he means like which platforms do we need to send the CV?
So I'll send you a link. So what I can do, Oshira, is I send you an email with all the links. But basically, there's lots of stations. There's the Austrian Space Forum, there's AstroCapsule, there's Euromonmas, there's Lunaris Research Center, there's MDRS, there's EarthMars, there's High Seas, there's Possum. Literally, there are so many of them, and some of them I don't even know yet about. Because some animal space mission are really, really well, famous and known, and others are a bit like smaller. Like for example, Habitat Matre is a bit less known than Austrian Space Forum, but still a form of analog space mission. So I'll send you an email so you have all the links, and then you can decide where you want to apply depending on your budget, depending on the location, depending on how much time you have, and yeah, hopefully you have a successful mission.
Yeah, that would help. I'll once you give me the links with the email, I'll forward them to all the participants so they can go and explore by themselves. And okay, we have a couple of questions from Vijay, and I would like to take this common question which many people have asked. Foreign candidates, how can they apply for European Space Agency's mission, like as analog missions, or even for NASA's analog missions? So, is there any way for them to try this thing, right?
So foreign, it depends, because the European Space Agency has I think now 24, 25 member states. So if you're a member state, then you can apply. But obviously, if you're from India or from a non-member state, then it's a bit more complicated to apply as an astronaut. Like the same way I'm not American, so I can't apply to NASA. But there are other agencies that are developing, and there are the analog space mission usually are not only for certain citizens. Like we don't have one that is mainly reserved. It's more the problem, for example, last year because of COVID, High Seas, which is happening in Hawaii, well, you couldn't go there unless you had either the visa to get there or you had an American passport. But otherwise, there's no reason for them to, put a limitation, because you usually spend your own money on it, or, you're being sponsored. But it's not the same as 26 or 25 member states who, via their taxes, pay for you to go to space. Okay, this is the reason why agencies can't send somebody who's foreign from their country or from their member states. It's because it's the taxpayer who pay for the astronaut job. But analog space missions, you're not limited by that. So, there's no reason for them to have a problem with your nationality.
Yes, and like there are various missions like Lunaris, Asclepius, who are like hiring students if you're skilled, if you have passion. So maybe you can try there as well. You can get the experience. Right?
Yeah.
So,
yeah, for example, Asclepius, it was only student for students, and Lunaris, I think it's not limited to students only. And Lunaris is in Poland right now, and Asclepius we based mainly in Switzerland. And when I started 2 years ago, AstroCapsule, we had many people from Switzerland, but we had a few foreign people. And now it's super international. We have people from Chile, from Canada, from the UK, from Germany, from it's really, really, really cool.
Yeah, Vijay has another question which says what type of analog missions they are hiring, and for what type of astronaut. So I think he is trying to ask, are there different types of analog missions through particular, for a specific thing, or are they just a complete mission?
So yeah, you can do different kinds of analog space mission depending on what you want to focus on. So sometimes you want to focus on the spacesuits. So for example, the Austrian Space Forum, they have massive spacesuits. They're really, really big, and you have I think they're almost autonomous. So they invest a lot of money on this, and they will therefore work on more extravehicular activity. We had those spacesuits that you see on the picture there, and they're not completely hermetic, and we did not spend most of our budget on this. We did spend some budget on it, but it was not the main focus. The main focus was, can we as students recreate a lunar base? Can we, run it? Can we do the experiments, etc., etc.? So for us, it was to replicate as authentic as we could a mission while being on a budget. other space missions that will like kind of replicate more the extreme part in the environment or the lack of gravity. So, for example, underwater space missions, and others, it's more the length. So I think it was about 10 years ago when they wanted to simulate, a travel to Mars, and they put people like for a year in a base. So sometimes it's the psychological aspect that you want, sometimes it's the habitat, sometimes the spacesuit, sometimes it's the experiment. And they will probably recruit people differently in the way that if you're a student, you don't have a year available. Okay, you usually have a week or two in between exams and in between internships. Okay, but if you're working or you're retired, then yeah, you have more time. Okay, so just because of this, you can already recruit differently and do different length. And yeah, you might not be ready to spend a year in a box, depending on your age. But sometimes later you're like, well, I'm done with work, I have money on the side, and then it's fine. So yes, obviously there are different space missions depending on the thing, but in general, it's more your choice. Like you choose basically where you apply depending on just where you are in life or what you really want to do.
Yes, I would love to add to that. Like, if you simply Google analog space missions and you go to the NASA site, you'll get like they categorize it into three categories. One is for specifically geology, then astrobiology, and their mission category. So you can explore there more. Again, he says, okay, what steps we have to take to reconnect again once the communication is lost? So you were explaining about the communication delay experiment that you did. So yeah, that's related, right?
Well, the main answer is troubleshooting. How would you do if your computer died right now? You would check if it's the battery, you would check if it's the Wi-Fi, you would check if it's a hardware problem. Like it's the same in space. It's like we actually had a communication problem during the mission, but we were asleep. It's only Mission Control Center who were like, oh my God, what's happening? Because they even had webcams in the base, and suddenly the webcams didn't give any feed. And, they were trying to contact us and it was not working. And we had another phone in case the Wi-Fi was shutting down. Okay, there was no network. So we had a special phone that we could use in case something terrible happened and we needed to get to them. But they didn't use it because they were like, well, look, they're probably fine, they're sleeping. It's probably a Wi-Fi problem. So then they called the people who were managing the base, and they said, oh, we just did I think it was a software update, and basically it shut down the Wi-Fi for 2 hours, which was why they couldn't communicate with us. But basically you would do the same in space. In space, you understand, okay, why is the communication down? Okay, try to reboot it, try to reshoot it. And then if you're on your own, then, you congregate the crew and you say, okay, now we are on our own. So if there's any problem, we need to be as autonomous as we can. We need to be careful, and we need to try to repair as much as we can communication, but it could be that we'll not manage. And that's it. It's like, it's the same for all of us, try to solve the problem as you can. And if you can't, adapt, improvise, overcome, find a way to make it work anyway, And obviously some missions, you need communication. Okay. For example, if you don't have an expert on site, for a certain experiment, and you need to talk to them back and forth to get information, then maybe you will have to abort the mission. That is a possibility, but normally you should have done well enough that you don't need them per se, that they're there as a safety procedure.
I hope that answers this question. And there's Akshat who says, in space, if any physical damage to a spacecraft happens, then how the team will repair it?
Sorry, what was the last part of the question?
In space, if any physical damage to the spacecraft happens, then how the team will repair it?
It depends. It depends what damage it is. For example, it was 2 years ago, there was a hole in the ISS, and obviously you try to fill it up, and it depends what kind of material you have available. You can't necessarily always do some welding in space, so it depends how structurally damaged it is. But sometimes you can 3D print an extra parts to it. Sometimes you have to evacuate. Sometimes what you can do is you could get in a Soyuz capsule, one of the capsule, maybe a Dragon capsule, so that that, for example, they're safe if they haven't been damaged, and you wait there, and then you wait for another rockets to send another capsule, which might contain the tools or the material that you would need to repair the spacecraft. So it's always basically you would have a protocol saying how bad is the damage, what do we have on board, can we do it, and if not, then abort and escape. Always safety first, okay? But you shouldn't say, oh my god, there's a hole, and just leave the ship. No, try to analyze what's going on, and the Mission Control Center will usually help you with this. So for example, there was an Apollo mission that went wrong, and they had a problem with the CO2 filtration system, and basically Mission Control Center was like, okay, what do you have in a spacecraft, what can you do? And then they found a way to make it work. Okay, and then they went back to Earth and then got the moon, but it's fine. So this is the kind of thing you can do. Okay, so assess what you have and find a solution, and if you can't, then you give up the mission, but otherwise don't.
Yeah, there's another question. She says, even if we have preserved food for consuming in space, carrying them in large amount to places like Mars, it's really challenging. So we are forced to grow them in the station itself. So like how we simulate that in the analogs.
So in the analog, you can really simulate agriculture quite easily, and they even have. So we were supposed to do this during my mission, but in the end it got cancelled. We had a robot that was supposed to help us analyze how our plants are growing and send us alerts saying, well, the soil seems to be too dry or too wet. Maybe add this. So you could have robots that could assist you to do this agriculture. And in analog space mission, like some stations have massive gardens, basically like greenhouses. They do a lot of it. We didn't have priority on this for our mission, but some of them really do. I think one of them is based in Spain. One of the universities is working massively on that kind of plants and just assessing what are the best plants for the kind of environment. Some plants, they need absolutely the right amount of sunshine and they wouldn't like, an artificial light. And others, they're super strong and they serve very well and you can use them for food and everything. So yes, you definitely do this in analog space missions and it's actually not complicated at all. It's quite straightforward.
Eleonore, will you give me a few seconds? I just have to inform the participants. We'll be sharing a link. Do fill in the Google form and give us your feedback. It will be valuable for assessing. So yeah, we'll share the link in a minute. Do fill in that form. So moving on to the questions. Oh, I see Karine has joined us. Hi, Karine. Thank you for joining us. And she says the Australian Space Forum has space suit simulators. They are autonomous with communication connectivity. They also include an exoskeleton to simulate movement restriction by pressurization. They also weigh the same as the suit on Mars would weigh, like adjusted for the gravity conditions. So I think that was the answer for some of the question, I guess. But
I
yeah,
think it
thank you
was
for
about
sharing.
the spacesuit. When I mentioned Australian Space Forum has like amazing spacesuits because they did a lot on this. Yeah, so yeah, so thanks for the extra details on them. Yeah, no, they look amazing. Like guys, really have a look at these spacesuits. It's like they're just massive. It's really really cool. Really really cool spacesuits.
Thank you, Karine, for sharing with us. And like in continuation of the first question, I had a question. You said that you had like the food that used to come was like I saw in the picture it was kind of normal. Was it like how we gave like dehydrated food similar to what
No.
we have on? Yeah.
No, it was all tin can food. So for 2 days we have fresh food, and then obviously after 2 days, like you don't have like cooling storage, so you use only tin can food. So no, it was not freeze dried. We did eat freeze dried food for one of the training camps we had for the extreme environment training camp, and it was really really good. I actually really really liked it. Like there was a cheese pasta, and there was a couscous, and there was, I don't know, like chicken curry. Like there was so many things like they were really really easy, and you just put hot water and eat them. I think I would probably get fat if I had this all the time because it's just so good and it's super nutritious. Like it works really well. But no, during the mission we had tin can food, and also we were cooking pasta or rice. We even managed to do pancakes. So it's actually quite amazing the number of things you can do with that food, and it's not fresh food at all, but it was really really good. I'm really impressed.
Yeah. Anand here has a question, which is the exact question I wanted to ask. I'm like wanted to get an answer for this. How can we start the Indian chapter for analog missions affiliated with the established facilities so that the Indians can experience the same without going to other countries?
So
Is
I'm
there?
not sure. So like, how could you do your own analog space mission in India? Was that
Huh,
is that
right.
okay? You can found it. I mean that how does it start? AstroCapsule started because two students had the idea to say, hey, let's make our own analog space missions. It exactly works like this, and obviously in India, because you have a very large population and your space program is quite taking off, you probably would have lots of people who would be motivated to do it. So it's just find motivated people, put on the paper exactly your ideas, like what is the goal of your space mission? For whom is it? Is it more only for students, or is it for the wider public? What do you want to get out of it, and with whom do you want to collaborate? Like, do you want to collaborate with Elon Musk, or do you want to collaborate with the Indian government, or do you want to collaborate with universities? What is your main aim? What do you want to simulate? What is your priority? For whom is it? And start working. It's happy to give you a hint or two. I didn't found AstroCapsule myself, so I don't have all the credentials, but I have a bit of idea. I can give you some contacts, and just go for it. There's no magic formula. You just have to get started.
Right. Anand, you can reach out to us. Maybe we can think something together and come up with one.
That'd be so cool. That'd be amazing.
Yeah, we are nearing our time. So I'll take this last three questions. Shreya wants to know, can you tell us more about the analog missions in which you're going to participate in the coming future? Future missions you're going to participate in, analog missions.
So is
Any
it for you
lined
or
up?
for me, the question?
For you.
Okay. No, not that, because maybe you have some plans. So for the moment, I don't have any on my agenda because I'm finishing my PhD, but I will probably apply to a master's at research station in Utah, and also to the one in the Arctic Circle, FMAS. And I probably wouldn't do missions longer than 3 weeks or a month because I'm going to be working on the side. But yeah, it's like the kind of mission I would be really interested in doing. The Austrian Space Forum, they're not looking for astronauts at the moment, but I'm usually checking what they do because I really like their mission. So I will probably try to apply there once they make a call. But yeah, I have to see what's next. This year, it's not planned. But sometimes, an opportunity comes and then you're like, oh, well, what the hell? Let's go and do this. So we'll see. Your guess is as good as mine.
So the second question is from Adar. She says, what happens in case of astronaut injury, especially one regarding the need for bed rest? So yeah, what medical assistance do we have?
So usually what happens when an astronaut needs a bed rest, for example, is you have an assessment that is done by the astronaut inside the base. So the medical officers, they send a report to the biomedical engineer. And depending on how the gravity and severity of it, then they will act upon it. So obviously, if you have an astronaut who's got a migraine, obviously it's you can't really work, but it will go away. You have medications that usually work, and it's not a serious thing, okay? If, however, they have extremely high fever and you're not sure why, then you have to understand, is it appendicitis? Is it the food? And if it's the food, are the other astronauts going to be sick? Is it a virus? If it's a virus, are the other astronauts going to be sick? Because one person down already compromises the mission. But if then it spreads to the others, then it's a problem. So you have to go through a massive checklist of where does it come from, how long is it going to be, and what tasks can they or not perform. And depending on the answers you get, you cancel the mission, you extract the astronauts. So it means that you would send a spacecraft, or obviously for an space mission, it's easier. You would just, send something that would then pick up the astronauts and bring them back to Earth. And then you continue the mission with one astronaut less. Or you just tell them, well, okay, well, we will take on your work, or we will have to cancel the experiments you were going to do, and you take your bed rest, and tomorrow you get back to work. But basically, the most important thing is really stay flexible, because you don't know, right? We had one of our astronauts had a massive headache during the mission, but it was probably he was just dehydrated. But they did a checkup. They checked if anything had happened, if any pupils that were dilated, if he had been hit in the head or anything. And if the assessment is fine and the biomedical engineer says it's okay, then they can stay in the base. And we continued, and that's it. And then it's just for the 1 hour where they were a bit resting and doing the checkup that we had to take upon his activities. And yeah, that's it.
Okay, so last question for today. Vijay asks, is there any competitive exam or license certification one needs to do for applying for astronaut position?
For the astronaut position itself, yeah. So obviously you have like exams. For me, I applied to ESA, but I didn't make it through the first round because I'm apparently a bit too young or not experienced enough. So I haven't done the exams this year. But obviously, yes, you do have exams online. What happens is that they will send you some of the cognitive tests that they will ask of you, and you can train for them. Okay, so this is all things that you can find, and you can also read Team Peake's book. He's an astronaut for the European Space Agency, and he basically tells you what kind of exams he had, what kind of evaluation, and he gives you an example of what you need to do and what you need to be basically to apply. So all of this you can actually find online, or buy a book on one of your bookshops. So you can find information. Yes. I hope that answered the question. I'm not sure.
Yes, it does. I was just searching for the questions. People are saying that was they're complimenting you. It was an excellent presentation, and they want your LinkedIn ID as well.
Perfect. Well, I'm going to stop sharing my screen then, so I can see if there's any extra comment that you guys might want to make. But otherwise, it was lovely to have all of you, and really just go for it. If you want to do space missions, it's a really wonderful opportunity. And for me, I applied because I wanted to see if I could be an analog astronaut, and it was the best thing I could do, because for me it was like, oh, I love this job, I love this, I want to do this for the rest of my life, and I wouldn't have had exactly the same thing in another case. So I'm really, really, really happy I did this, and I really recommend it to all of you.
Yes. Thank you, Eleanor, for giving us such an insightful presentation, I would say. There were so many things, so many new information people had to, Now, I hope they go home, look once again to the key takeaways, process it, and find the path they want to, if they are really interested into analogs. So with this, I think we are nearing, okay. Yeah, Terry says you can become a virtual analog astronaut at Habitat Marte. Yes,
this is how we met.
Exactly. Like Karine, myself, and Eleanor, we were all part of the mission 89, which was a virtual analog space mission conducted by Habitat Marte. So you guys can check that as well. For beginners, I would say it is a great experience. You'll connect with a lot of people, and you'll get a stage to put your thoughts out. So yes, Karine has also shared the links, I guess. Yes, thank you, Karine.
Yeah, Karen is fantastic. She's a really great person. So you can badger her too and ask the questions. She's a great person of reference.
Okay then, so with this, we end our first day of the webinar series. Thank you, Eleanor, once again, and thank you to all the participants who had joined us and asked really good questions. So see you all tomorrow again at 5, and tomorrow we'll talk. It won't be a very professional presentation, I would say, but
you do perfect. You're going to be amazing.
Yeah, but we'll discuss a bit more about the underwater analogs missions. So see you all there tomorrow. Thank you, Eleanor. Once again.
Thanks to you. Thanks for the honor, and have a wonderful evening, all of you, and a great start in the weekend.
So I've stopped the recording for once. Yeah.